Good afternoon, students. In this lecture, we are going to study what is meant by oxidizing agent or oxidant and what is meant by reducing agent or reductant. First of all, what is meant by oxidizing agent? Oxidizing agents are the substances which causes oxidation of another species and itself undergoes reduction, called as oxidizing agent. While reducing agents are the substances which causes reduction of another species and itself undergoes oxidation. Here one example I have right here: cell reaction in Daniell cell, zinc metal plus copper plus 2 ions, it gives zinc plus 2 ions and copper metal. For this reaction we are already studied in previous lecture. Therefore here charge on zinc metal is 0. Charge on copper plus 2 ion is plus 2. Charge on zinc plus 2 ion is plus 2. And charge on copper is 0. We know that one definition of oxidation and reduction is increase in oxidation number is called as oxidation and decrease in oxidation number is called as reduction. From these oxidation numbers, it indicates that oxidation state of zinc is changes from 0 to plus 2, that means increases. It indicates that zinc metal undergoes oxidation. Zinc metal undergoes oxidation, therefore it is reducing agent. That is, what is meant by reducing agent? It is the species which causes reduction of another species and itself undergoes oxidation. Therefore, zinc metal is the reducing agent. Reducing agent. Because it causes reduction of another species, that is reduction of copper plus 2 ion and itself undergoes oxidation. That means in this reaction zinc metal act as a reducing agent. Then what is meant by oxidizing agent and which is the oxidizing agent in this reaction? What is meant by oxidizing agent? It is the species which causes oxidation of another species and itself get reduced. Therefore in this reaction copper plus 2 ions get reduced by accepting electrons lost by zinc metal. Therefore copper plus 2 ions is the oxidizing agent. Oxidizing agent. Then what is meant by oxidation number? Oxidation number of an element in a compound is number of charges it would carry by complete transfer of one or more electron. What is oxidation? Oxidation number of an element oxidation number of an element in a compound is defined as electrical charge it would carry. Electrical charge it would carry by complete transfer of one or more electron. one or more electron. This is the definition of oxidation number, or it is also called as oxidation state. For 1 mark, this question will be asked, define oxidation number or define oxidation state. Then what is exactly oxidation number and oxidation state? There are rules to assign oxidation number. Next point is rules to assign oxidation number. Rules to assign oxidation number. First rule is oxidation number of each atom in elemental, uncombined or native state. Elemental, uncombined or native state, it is also called as free state, is 0. What is rule number first? Oxidation number of each atom in free state is 0. What is meant by free state? For example, oxidation number of oxygen, nitrogen, chlorine, sulfur, phosphorus, ozone is 0. These are the compounds in which each atom having 0 oxidation state, because these elements are in free state or uncombined state. Therefore, oxidation number is 0. Oxidation number is equal to 0. Then, second rule, oxidation number of alkali metal. What are the alkali metals? That is group first element, that is lithium, sodium, potassium, rubidium, cesium, francium. These elements are alkali metals. Oxidation number of alkali metals in their compounds is always +1. Oxidation number of alkali metals is equal to +1. Then oxidation number of alkaline earth metals. Alkaline earth metals means group second elements. Is always +2. What are the group second element? You are already studied group first and second element. Beryllium, magnesium, calcium, strontium, barium and radium are the group second element. They shows +2 oxidation state in their compounds. Then third, oxidation number of monoatomic ion. Oxidation number of monoatomic ion is equal to its charge. For example, monoatomic ions, for example, Na plus, then Cl minus, then sulfide ion, sulfur -2, calcium +2, then oxygen -2. These are the monoatomic ion. Monoatomic means ion which consists of only one atom that are called as monoatomic ion, and all these are monoatomic ions. Therefore, its oxidation number is equal to its charge. That means charge on Na plus is equal to +1. Therefore, oxidation state of Na plus is +1, Cl minus -1, sulfur -2 -2, calcium +2 +2, oxygen -2 -2. This is the third rule. Oxidation number of monoatomic ion is equal to its charge. Then next rule is oxidation number of oxygen. Oxidation number of oxygen is generally -2. Fourth rule is oxidation number of oxygen is generally -2 except in peroxide. What is meant by peroxide? Compounds in which oxygen-oxygen linkage is present, that compounds are called as peroxide. What is the fourth rule? Oxidation number of oxygen is always generally -2 except in peroxide it is -1. And another exception for oxidation number of oxygen, in oxygen difluoride, oxidation number of oxygen is +2. What is fourth rule? Oxidation number of oxygen is generally -2. For example, in water it is -2. Then hydrogen peroxide, in which oxygen-oxygen linkage is present, therefore it is peroxide and its oxidation number is -1. This is the exception for oxidation number of oxygen. Oxidation number of oxygen is generally -2 except in peroxide it is -1. What is meant by peroxide? Compound in which oxygen-oxygen linkage is there, that compounds are called as peroxide. And another exception, oxidation number of oxygen is superoxide. This is potassium superoxide, in which oxygen shows -1/2 oxidation state. Another exception for oxidation number of oxygen in oxygen difluoride. In OF2, oxidation number of oxygen is +2 because fluorine is more electronegative than oxygen. Therefore, fluorine does not show positive oxidation state, but oxygen shows positive oxidation state if it is attached to chlorine. Then oxidation number of hydrogen. Fifth rule, oxidation number of hydrogen is either +1 or -1 depending on it is attached to metal or non-metal. When hydrogen is bonded to non-metal, then it shows +1 oxidation state, and if it is bonded to metals, which are metals, group first and second elements are metals. If it is attached to metals, then it exhibit -1 oxidation state. Fifth rule, oxidation number of hydrogen is either +1 or -1 depending on it is bonded to metal or non-metal. If it is attached to non-metal, then it shows +1 oxidation state. If it is attached to metal, then it shows -1 oxidation state. For example, in hydrogen chloride, HF, we know that fluorine is a non-metal, therefore hydrogen shows +1 oxidation state. Second example, in water, oxygen is non-metal, therefore hydrogen is attached to non-metal and it exhibits +1 oxidation state. What is the? When hydrogen shows -1 oxidation state if it is attached to metal. For example, lithium hydride. Lithium is the metal from group first element, and we know that, as say earlier, alkali metal always shows +1 oxidation state. Therefore, lithium is alkali metal, it shows +1 oxidation state. Obviously, hydrogen shows -1 oxidation state because it is bonded to metal. Next example in calcium hydride. Calcium hydride. We know that calcium is alkaline earth metal, it shows +2 oxidation state, and hydrogen shows -1 oxidation state because it is attached to metal. Then oxidation number of halogens. Next rule is sixth rule. Sixth rule is oxidation number of halogens. What are halogens? Now question arises, what are halogens? Group 17 elements are called as halogens. That is fluorine, chlorine, bromine, iodine. These are the halogens, that is salt forming element. Oxidation state of halogen. All halogen shows -1 oxidation state, out of which fluorine always shows -1 oxidation state. Fluorine always shows -1 oxidation state because it is most electronegative element in the periodic table. But in HF, hydrogen fluoride, hydrogen chloride, hydrogen iodide, and hydrogen bromide, we know that all halogens are non-metal. Therefore, here hydrogen is attached to non-metal, therefore it shows +1 oxidation state, and hence halogen shows -1 oxidation state. -1, -1, and -1. But when chlorine, bromine, and iodine is bonded to oxygen, then it shows +1 oxidation state. For example, in these compounds, chlorine is attached to oxygen, and in second compound also 2 chlorines are attached to oxygen. In these compounds, chlorine shows +1 oxidation state. Here also chlorine shows +1 oxidation state. These are the exceptions. What is the rule number 6? Oxidation state of all halogen is -1, but in addition to this, if chlorine, bromine, iodine is attached to or bonded to oxygen, then it exhibits +1 oxidation state. Then next rule is algebraic sum of oxidation state of all atoms in a neutral molecule is equal to 0. And next rule is 8th rule. Algebraic sum of oxidation number of all atoms in polyatomic ion is equal to its a charge. For example, how to explain rule number 7th and 8th? What is the rule number 7th? Algebraic sum of oxidation state of all atoms in a neutral molecule is 0. What is meant by neutral molecule? It has no any charge, that is neutral molecule, then is equal to 0. And what is rule number 8? Algebraic sum of oxidation state of all atoms in a polyatomic ion is equal to its charge. How to explain these two rules? By example. Example, assign oxidation number of underlying elements. Underlying elements. For example, HNO3. In this example, we have to calculate oxidation number of nitrogen. First example. And second example, SO4 minus 2. In this example, we have to calculate oxidation number of sulfur. According to rule number 6, algebraic sum of oxidation number of all atoms in a neutral molecule. First example is a neutral molecule because it has no any charge, either plus or minus. Therefore, according to, we know that oxidation number of hydrogen is either plus 1 or minus 1. Hydrogen shows plus 1 oxidation state if it is attached to non-metal. Here nitrogen is non-metal, hydrogen is attached to non-metal, therefore it shows plus 1 oxidation state. Oxidation state of oxygen is generally minus 2, except in peroxide it is minus 1, in superoxide it is minus 1 by 2. Therefore, how to solve this problem? Oxidation number of hydrogen plus oxidation number of nitrogen plus, here one oxygen shows minus 2 oxidation state, therefore 3 oxygen shows 3 multiplied by oxidation number of oxygen. By substituting values in this equation, oxidation number of hydrogen is plus 1 because it is attached to non-metal nitrogen. Therefore 1 plus oxidation number of nitrogen it is, we have to calculate oxidation number of nitrogen, then 3 multiplied by oxidation number of oxygen minus 2 and is equal to, according to rule number 7th, algebraic sum of oxidation number of all atoms in neutral molecule is equal to 0. This is neutral molecule, therefore is equal to 0. By solving this, 1 plus oxidation number of nitrogen, 3 multiplied by minus 2 is equal to minus 6 is equal to 0. Therefore, oxidation number of nitrogen is equal to minus 1 plus 6 is equal to plus 5. Oxidation number of nitrogen is plus 5. It should be noted that oxidation number is always denoted by either plus or minus. Then in second example, we have to calculate oxidation number of sulfur, and according to 8th rule, algebraic sum of oxidation number of all atoms in a polyatomic ion. What is meant by ion? Species that carry either positive or negative charge, that is called as ion, and it consists of 4 atoms, therefore it is polyatomic ion. Then algebraic sum of oxidation number of all atoms in polyatomic ion is equal to its charge. It is ion because it having minus 2 charge, and algebraic sum is equal to -2. Oxidation number of sulfur plus, here 4 oxygens are there, therefore 4 multiplied by oxidation number of oxygen is equal to charge on polyatomic ion is equal to -2. Oxidation number of sulfur plus 4 multiplied by oxidation number of oxygen. Oxygen generally shows -2 oxidation state except in peroxide. It is not peroxide, therefore oxygen shows -2 oxidation state. Therefore 4 multiplied by -2 is equal to -2. Oxidation number of sulfur -8 is equal to -2. Therefore oxidation number of sulfur is equal to -2 plus 8 is equal to +6. This is your answer. Oxidation number of sulfur +6. In this way we can assign oxidation number of any element in any compound according to these rules. And for 2 marks or for MCQ, one question will be asked on this point, oxidation number. Then we will stop here.